Nenomatica, where mathematics meets YouTube excellence. In this lesson, we will solve a quadratic equation by the method of completing the square, following the exact algebraic steps shown in the reference solution. The problem is 3x squared plus 4x minus 15 equals 0. Step 1. Factor out the 3 from the quadratic part. This gives 3 times the quantity x squared plus 4 thirds x minus 15 thirds equals 0. Step 2. Since 3 is not equal to 0, the factor inside the parentheses must be 0. Write 3 not equal 0, and x squared plus 4 thirds x minus 5 equals 0. We restate the same equation to follow the given layout. X squared plus 4 thirds x minus 5 equals 0. Step 3 in the transformation. Move the constant to the right side. X squared plus 4 thirds x equals 5. X squared plus 4 thirds x plus 4 ninths equals 5 plus 4 ninths. The left side is now a perfect square, namely x plus 2 thirds quantity squared. The right side 5 plus 4 ninths is 45 ninths plus 4 ninths, or 49 ninths. Therefore, left side becomes the quantity x plus 2 thirds squared equals 49 over 9. Take square roots of both sides. X plus 2 thirds equals plus or minus 7 thirds. Now solve the two linear cases exactly as written in the reference solution. First, x plus 2 thirds equals 7 thirds gives x equals 7 thirds minus 2 thirds equals 5 thirds. Second, x plus 2 thirds equals negative 7 thirds gives x equals negative 7 thirds minus 2 thirds equals negative 9 thirds, which is negative 3. Therefore, the solutions are x equals 5 thirds and x equals negative 3. In this lesson, we will solve a quadratic equation by completing the square, following the exact step order shown. The equation is x squared minus x over 6 equals 7 over 6. First, identify the coefficient of x. It is negative 1 over 6. Half of that is negative 1 over 12, and squaring gives 1 over 144. Add 1 over 144 to both sides. Now, the left side becomes a perfect square trinomial. It factors as left parenthesis x minus 1 over 12 right parenthesis squared. On the right, 7 over 6 plus 1 over 144 equals 169 over 144. Take the square root of both sides. So x minus 1 over 12 equals plus or minus 13 over 12. Solve the two cases. When the right side is positive 13 over 12, x equals 13 over 12 plus 1 over 12, which is 14 over 12. That simplifies to 7 over 6. When the right side is negative 13 over 12, x equals negative 13 over 12 plus 1 over 12, which is negative 12 over 12, or negative 1. Therefore, the solutions are x equals 7 over 6 and x equals negative 1. In this lesson, we will solve a quadratic by completing the square, carefully following the exact step order shown. Here is the example we will solve. Step 1. Move the constant term to the right side. That gives x squared minus 12x equals negative 35. Step 2. Complete the square by adding 36 to both sides. We choose 36 because half of 12 is 6, and 6 squared is 36. Here is the geometric picture for intuition. Imagine a square of side x. Subtracting 12x means removing two rectangles each of size x by 6. To complete a perfect square, we must add a small 6 by 6 square, which is 36. Step 3. Rewrite the left side as a perfect square. We obtain left parenthesis x minus 6 right parenthesis squared equals 1. Step 4. Take the square root of both sides. That gives x minus 6 equals plus or minus 1. Step 5. Plus or minus 1. Step 5. Solve the two simple equations. From x minus 6 equals 1 we get x equals 7. From x minus 6 equals negative 1 we get x equals 5. Therefore, the solutions are x equals 7 or x equals 5. Quick check. Substitute x equals 7 and x equals 5 back into the original equation to see that both satisfy it. Summary. We followed In this lesson, we will solve a quadratic by completing the square. Our equation is 2x squared minus 5x minus 12 equals 0. We'll follow the algorithm step by step and explain each move visually. Step 1. Factor out the leading coefficient from the quadratic and linear terms. 2 times the quantity x squared minus 5 has x minus 6 equals 0. Then divide both sides by 2 to simplify the inside expression. Step 2. Move the constant to the right side so that only x terms remain on the left. Step 3. Complete the square. The idea is 4x squared plus bx. Add the square of half of b to make a perfect square. Here, the coefficient of x is negative 5 halves. Half of that is negative 5 fourths, and its square is 25 over 16. We add the same number to both sides. Step 4. The left side is now a perfect square. Write it as the quantity x minus 5 fourths squared. On the right, write 6 as 96 over 16 and add to get 121 over 16. Step 5. Take the square root of both sides. The square root of 121 over 16 is plus or minus 11 over 4. Step 6. Split into 2 linear equations and solve for x. First, x minus 5 fourths equals 11 over 4, which gives x equals 4. Second, x minus 5 fourths equals negative 11 over 4, which gives x equals negative 3 halves. To build intuition, let's verify the roots on a graph. We will plot y equals 2x squared minus 5x minus 12. The curve should cross the x-axis at x equals 4 and at x equals negative 1.5. Final answer x equals 4 or x equals negative 3 halves. Example. Write the problem clearly on our board. Step 1. Factor out 5 and write the grouped form. Then, divide both sides by 5 to simplify the equation exactly as shown. Step 2. Move the constant to the right side. Step 3. Complete the square. Half of 6/5 is 6/10, and 6/10 squared is 36 over 100. Add this exact value to both sides. Step 4. The left side is now a perfect square. On the right, convert 8/5 to 100ths and add 160 over 100 plus 36 over 100 equals 196 over 100. Step 5. Take the square root of both sides. Step 6. Solve the 2 linear equations. Subtract 6/10 from both sides in each case, then simplify. Therefore, the solutions are x equals 4/5 or x equals negative 2. Here's the example problem. Step 1. Move the constant term to the right side. We write x squared minus 6x equals negative 9. Step 2. Add the square of half the x coefficient to both sides. Half of 6 is 3. 3 squared is 9. So add 9 on the left and 9 on the right. Step 3. The left side becomes a perfect square trinomial that factors to, open parenthesis, x minus 3, close parenthesis squared equals 0. Step 4. Take the square root of both sides. The square root of, open parenthesis, x minus 3, close parenthesis squared, equals the square root of 0. Step 5. Simplify the square root of the square. We get x minus 3 equals 0. Step 6. Solve for x. Therefore, x equals 3. Because the perfect square equals 0, the solution x equals 3 is a repeated or double root. Display the example and the problem. Step 1. Add the square of half the coefficient of x to both sides. Here b equals 3. So b over 2 is 3 over 2, and its square is 9 over 4. Show the rule. Now, apply it to our equation. Step 2. Rewrite the left-hand side as a perfect square trinomial. Show the perfect square rule. Apply it to obtain an equivalent squared binomial. Step 3. Take the square root of both sides and include plus or minus. Show the square root property. First, take square roots symbolically. Then, simplify the right-hand side to plus or minus 3 over 2. Step 4. Split into the 2 linear possibilities and solve each. Write the 2 cases. Solve to obtain x equals 0 or x equals negative 3. Write the equation clearly. Step 1. Make the linear coefficient easy to see. That is, write negative 1/5 times x. Step 2. For completing the square, we take b over 2 and then square it. Here, b equals negative 1/5. Then b over 2 equals negative 1/10. Squaring gives 1 over 100. Step 3. Add that exact quantity, 1 over 100, to both sides. This creates a perfect square on the left. Step 4. Factor the left side as a perfect square. It becomes left parenthesis x minus 1/10 right parenthesis squared. Step 5. Now simplify the right side using a common denominator of 100. 6 over 5 equals 120 over 100. Adding 1 more over 100 gives 121 over 100. Step 6. Take the square root of both sides. We get x minus 1/10 equals plus or minus 11 over 10. Step 7. Solve the two simple linear equations. First, x minus 1/10 equals 11 over 10. So x equals 12 over 10, which simplifies to 6 over 5. Second, x minus 1/10 equals negative 11 over 10. So x equals negative 10 over 10, which is negative 1. Therefore, the solutions are x equals 6 over 5 and x equals negative 1. In this lesson, we will solve a quadratic with a parameter using the method of completing the square. Our goal is to move carefully, one clear step at a time, and to visualize why each move works. Here is our example. We will solve the equation x squared minus 2bx plus 15 equals 0 for the variable x in terms of the parameter b. Step 1. Move the constant term to the other side. That isolates the quadratic and linear parts together on the left. Step 2. To complete the square, look at the x coefficient. The coefficient of x is negative 2b. Half of that is negative b, and when you square negative b, you get b squared. That is exactly the term we must add to both sides. Step 3. Add b squared to both sides. Step 4. The left side is now a perfect square, quantity x minus b squared. Step 5. Take the square root of both sides. Remember to include both the plus and the minus square root. Step 6. The square root of quantity x minus b squared is the absolute value of x minus b. For solving this quadratic, we proceed with the two signs together as x minus b equals plus or minus the square root of b squared minus 15. Step 7. Add b to both sides to isolate x. That gives the two solutions x equals b plus the square root of b squared minus 15, and x equals b minus the square root of b squared minus 15. We summarize this compactly using plus or minus. Visually, example, we will solve the quadratic 3x squared minus 2x plus c equals 0 using the completing the square method, exactly following the listed steps. Step 1. Factor out the coefficient of x squared from the left side. Step 2. Since 3 is not 0, we can divide both sides by 3. This yields the simplified quadratic. Step 3. Move the constant term to the right side. Step 4. Complete the square. The middle coefficient is negative 2/3, so 1/2 of that is negative 1/3, and its square is 1/9. Add 1/9 to both sides. Step 5. Take the square root of both sides, remembering the plus or minus. Step 6. Split into the two cases and isolate x to get the solutions. Therefore, the solution set can be written compactly as x equals 1/3 plus or minus the square root of 1 minus 3c. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.